Hi everybody, my name is Trond Mikkelbust. I'm the current CTO of Hammerspace, but today I'll probably be speaking more in my capacity as the Linux NFS client maintainer. And what I'd like to talk about is some of the recent changes that have been made to the kernel NFS client, and a little bit also about how we see the roadmap moving forward, and what's driving that roadmap. So let's start with the first question. What is actually driving NFS in the enterprise today? As you know, NFS has been declared dead so many times at this point, and yet it keeps coming back. In this case, it's mainly mainly been the AI revolution. The fact that you need these huge data centers, filled to the brim with servers, each one of them running, with several tens or in some cases, maybe even hundreds of GPUs, and the vast amounts of data that those consume in order to train the AI models, large language models and generative AI and that sort of thing. So you probably saw this slide earlier today when David was presenting. But it's important to note what kind of requirements these large language models are imposing on us. It's extremely hard to serve up data at a fast enough rate without the help of a parallel file system. Typically this particular customer has a performance requirement of roughly 12.5 terabyte per second with today's models. The next generation is probably going to be an order of magnitude beyond that. There are typically several tens of petabyte of data that's needed to be feeding these clusters, and as I said, there's the GPUs are in the thousands or tens of thousands. And in order to feed that, you need data servers in the thousands of nodes. So in order to benefit as much as possible from sort of multiple sources, standardization is very much a requirement. There are plenty of proprietary solutions for parallel file systems. They all tend to have the requirements that you need special drivers, special this and that in order to run them. By using a standards-based model, you can have clients run out of the box, delivered by your software vendor. You do not need to supply change your infrastructure in order to adapt to the requirements of the storage that you're using. And this is very much driven a lot of the conversations in the ITF and in the last few years. One of the requirements that we have in the Linux NFS community in general, and Chuck is here to keep me honest about that, is that we like to make sure that everything is standards-based. And there are good reasons, beyond just customers' requirements for that. As a maintainer, I need to understand, the code that I'm developing. I need to understand, whether or not some feature that I find is a bug, or if it's something that the protocol requires me to do, or if it's something that I can optimize, or even sometimes remove. With Linux being largely documented by code rather than by the standard method of sort of writing up papers beforehand. The protocol basically keeps us honest and ensures that we know what the contents of the kernel are and what we can do with it. So the other thing that standards do, obviously, is they keep vendors honest. It's a community-driven process. Everybody who wants to have a voice, is able to participate. And technically, the ITF doesn't recognize companies. Everybody who's participating is actually participating on their representing themselves rather than a company interest, and that too, helps keep things honest, keeps make sure that not just the Linux community, but also other communities, BSD, etc., and even larger vendors can be represented through that method. So let's talk a little bit about how PNFS and the standards-based file systems work. PNFS is basically a way of splitting the architecture of NFS into two separate parts. You've got the metadata part, you've got the data part. And the client, basically talks metadata, talks stateful, talks state with the metadata server. And once it has data to read or write, it talks directly to the NFS server. So this model sort of goes back really into the early 2000s. It was itself a result of a standardization process involving several vendors. As a result, it's a little it was initially not well adopted due to sort of various things. One was, the lack of a proper market for it. HPC was never really a big thing until, the AI workloads appeared. The other thing was that the vendors found themselves competing with other scale-out architectures. As David mentioned earlier today, you had Isilon that turned up and basically killed the enterprise PNFS market, at least for a while, and made it simpler to implement because you didn't have the complicated clients that needed to know advanced versions of NFS v4. They could continue using NFS v3 and hobble along until the bigger data requirements came along in the last few years. So let's talk a little bit about what we have done in recent years in NFS v4.2. There's been a constant optimization of the various operations that the NFS client sends to the servers. Compound operations, which were introduced in NFS v4 sort of back in the early 2000s, never really were able to make use of the optimization that compounds promised, largely due to the POSIX API that they are constantly required to follow. However, the introduction of new modes of operation, in particular, the ability to use delegations, which those of you who are more familiar with S&B will know as leases, meant that clients were able to cache not just data and attributes, but also state, and that led to a requirement for more complex compounds to deal with the fact that you have to recover these things, you have to be able to return them efficiently, and that sort of thing. What's more, we added in, we were able to add in a few new additions to the protocol itself. NFS v4.2, unlike previous generations of the NFS v4 protocol, allows for extensions sort of beyond the basic NFS v4.2 set of operations that were sort of written down in the RFC back in the days. So this process has been used, in fact, on several occasions in the last 10 years to add more complex operations in order, as we've learned sort of how better to use the protocol and what the holes in the protocol were that were sort of preventing us from making full use of the potential. One of the main things, in my view, that was added in fact, very, very recently, is the ability to have a delegation that not just allows the client to be, the source of truth for the data and the simpler metadata. It also allows it to act as the source of truth for the timestamps. This basically eliminated 80% of the get-outer traffic, because pretty much every stat call that is being put on the wire by clients that are doing I/O tends to be just in order to ask, what is the M time, what is the A time for this file, so that it can report it to the application. And as most of us know, in most cases, the application doesn't make use of that information. So the ability to cache it and synchronize at the end of the I/O is extremely valuable, and eliminates most of the attribute traffic within our setup. The other optimization that was made is around file opens and closes. In the original version of NFS v4.2, it was typical that you needed several round trips just in order to create a file, because not only do you need to open the file, but in order to get proper only once semantics, there was an extra step whereby you saved the attributes, or you saved a cookie in the attributes, and the client would then use that to determine that, yes, it did create this file, and then it would have to overwrite the attributes. These days we're seeing file systems turn up that allow you to store these cookies as extended attributes and other places in the metadata. So that cuts down your create operations by a factor 50%. And then the fact that you have these delegations, the attribute delegations in the first place, basically means that you can cache open state, you can cache, you can make the close operation asynchronous, and so really in order to open a file, write some data, and then close it, the number of synchronous operations basically gets reduced to you have the open, you have the write, and then you can cache the close. Yes? Question?
I assume the changes are both in server and client.
Yes.
In your previous slide number 5, where is the actual NFS server and what version it should be in the three boxes that you have here, the green box and the NAS? Where is the NFS server and what version it has to be?
So in order to use attribute delegations, your server has to support NFS v4.2, and it has to implement the extension that is in the process of being finalized right now in the IETF. It's at this point it is the wire protocol, etc., is fully determined, which is why we have taken it into the NFS client I believe Jeff Layton has been working on a Linux server implementation for it. So, but yes, you need NFS v4.2 in order to use this.
Would that be on the metadata server or even on the NAS?
That's on the metadata server.
Not on the NAS. NAS
No.
can be all version based.
Yes, your storage can be any NFS, or you can, if you're using there are different versions of PNFS. You can be using Flex Files, which uses NFS v3. You can use Files, which is NFS v4.1, or or there are various block-based protocols. So in addition to the excess protocol chatter, there's also been a lot of work on other performance enhancements. Not too long ago we introduced the ability to set up multiple connections. This basically allows the TCP stack to perform better, typically by allowing the use of bonded networks and also accelerations within sort of standard networking cards. And there's the other set of improvements, tend to be around durability, the ability to write mirrored data, and so building highly available systems for advanced data nodes. Okay, we can skip. So let's talk a little bit about what the general roadmap, at least as I see it, is for the NFS evolution, being driven by high performance storage and the AI thing. I mean, we've already seen the parallel NFS. We've seen how Flex Files allows you to aggregate NFS v3 clients to act as a single storage scale with linear scalability. We've seen how you have the ability to do multiple connections. The attribute delegations, that I mentioned earlier, just going in. And in addition, we just merged some code to allow faster failover in situations where you're using PNFS with Flex Files. Basically by allowing the client to notify the metadata server what happened while the metadata server was rebooting. So basically, if the client was writing during that period, then the metadata server would either have to scan all the open files that it knew of before the reboot happened, in order to see if they changed in any way, or you'd have to have a notification mechanism to allow the client to tell it what did actually change, and by doing the latter, basically that allows the server to come up much faster and avoid this unnecessary scanning. Another thing that is being pushed is for when you have clients and NFS servers that are co-located, which is often the case in containerized environments. You know, if you're running in a container and you have another container on the same node acting as a NFS server, then there are optimizations that can be done to avoid the network hop between these two containers. And since they're running on the same hardware, they're running in the same, on top of the same kernel. One of the things that can be done is to basically just allow the client to, with certain restrictions, open the file directly on the server and do I/O directly through the kernel without going over the network. This has been seen to give significant performance improvements in certain areas, and so is one of the things that we're hoping to get in relatively soon. The other thing that is also being driven by these AI workloads, the need for data durability and high availability essentially means that if you want to store the data in a capacity efficient way rather than just doing pure mirroring, then you really need something like erasure coding. So one of the things that we are trying to organize within the ITF at this point is a drive towards adopting erasure encoding standards for the client. The reason for doing this on the client, is it's the only way to scale. When you have sort of several tens of thousands of clients writing, several tens of terabytes per second. If you were to feed that through a server that then has to erasure code and then write the erasure coded data onto sort of separate servers, you are introducing a bottleneck in the system. And you are
this is success. This is another example of success. This is where controller one does something.
Lastly, the final sort of thing that's being driven again by these AI workloads is improved security and privacy for your data. NFS has long supported the RPCSec GSS RPCSec GSS standard for protecting data. However, much of the work on accelerating privacy has tended to center more around improving the performance of TLS, rather than the older RPCSec, despite the fact that that tends to be more prevalent in enterprise storage settings. TLS is obviously being driven more by the fact that you have web servers, and so we have already standardized TLS for use within RPC and NFS. What remains to be done there is really extend it into parallel file systems, and allow its use within PNFS. Any questions? Yes.
In the roadmap slide, do you also have information on which NFS kernel supports each of them and which NFS server is needed for those features? Do you have those details?
So most of the attribute delegation stuff just went in. So it'll be in 6.11 when, well, it'll be, 6.11 just came out this weekend. So, so you'll find it there. You know, a lot of the more futuristic things, you know, we'll see when that lands.
Is the existing ones? The existing ones, the ones
Yeah.
on the slide?
Yes.
Linux kernels have support for that?
Yeah. 6.11. 6.11.
11.
Yeah. Yeah. Yep.
To answer my first question, the second question, where's the draft describing client TC such that layouts, or is it separate layout, or is it flexible?
Sorry, can you repeat that?
You describe client PC as a capability that's being, I think it's being added to Flex files, or is it as a layout?
It's being.
Object layout already has.
No, we're trying. I said we're trying to motivate. You know the.
So there is no draft.
There is a draft that was, I believe, was presented at the July ITF meeting, but it's literally just a talking point. It's a personal draft at this point by Tom Haynes.
I see. So one second question. What is the barrier to already using TLS for RPC when the data server supports it?
Right now, it's just the protocol itself. You know, it doesn't have. There is no way for the server to tell the client that it should be using TLS, or for them to negotiate. You know what kind of certificates need to be presented, that sort of thing. So it's literally just a question of updating the protocol. Any other questions?
Okay. So the question has to do with...
All right. Thank you everyone for your time.